Welcome back everyone. In this lesson we're going to begin to create our player object. This is going to be the player scene, which is going to hold the player, its collider and the camera, and from there we're going to begin scripting the player. So to begin, let's go up to scene here and we're going to create a new scene. It's going to be of type kinematic body right here. Now this is very similar to the 2D kinematic body, which basically allows us to have some sort of physics interactions. It allows us to move along surfaces, collide with various different things. It's really good for characters and character controllers pretty much. So I'm going to rename this here to player. I'm going to save it as player.tscn. And as a child of this node, we're going to be creating, first of all, a collider. So we'll just look up collision shape right here. And this is going to be basically what the sort of size of the player, what they can collide with. So we'll set the shape here to be a new capsule shape right here. Right now it's a bit odd, so what we're going to do is we're going to select the capsule shape. We're going to set the radius to 0.5 and the height to 1.5. Now we need to rotate it and position it, so in the transform drop down here, we're going to set the rotation degrees to 90 on the X, so it's vertical now, and 1.25 on the Y translation, so it is just sitting above Y0 right here. Okay, great. So we got our player right here. Now what we need to do is add in the camera, and the camera is going to be what we see through the player's eyes. We're going to then be able to move this camera around with our mouse. So for the camera, I'm going to right click on player, add child node, and we are going to add in a camera right here. By default it's positioned down at its feet. We want it to be a bit higher up, so I'm going to set the Y position of the camera here, the Y translation, to be 1.5. We want it to actually be 2.5, so it is sitting just above the player's head right here and looking outwards. And in fact, we can click on the preview button right here in the scene view to have a look through the camera and through the player's eyes. Alright, great. So we got that, we got the camera set up. Now what we need to do is set up the player's weapon. We need to set up the weapon that the player is going to have on their screen so we can see what we're holding on to. And to do that, we're going to open up our models folder here, weapon, and I'm going to drag in the shotgun.obj. Make sure it is going to be a child of the camera object, because when we do look around, we do want the shotgun, the gun model, to follow the camera around wherever we look. Okay, so we select the model. I'm going to rename this here to be our gun model. Now in the inspector, I'm going to set the translation to be 000, so it is nice and centered here. You might notice it's also pretty small, so what we need to do is increase the scale a bit. I'm going to set the scale here to maybe 5 by 5 by 5. That's still a tiny bit small, so let's actually increase it to 10 by 10 by 10. We'll set the Y rotation degrees to 180, so it is flipped around and facing the right way here. And then what we can do is drag it forward a bit, maybe move it down a bit, move it to the right a bit, and let's look through our camera. So I'm going to select the camera here, click on preview, and there we go, we've got a gun model. Now let's just reposition it a bit so it's in a bit of a better position. Alright, so I'm going to set the X translation here to be 0.2. I'm going to set the Y here to be 0, which is a bit high, so maybe negative 0.5. Nope, we'll probably want to make that negative 0.2. There we go. And Z, we'll put that at negative 0.6, something like that. So here we go, we've got our gun model. We got that pointing outwards, and we are also needing to create a new node which is a child of the gun model. Actually, it doesn't have to be the child of the gun model. In fact, we are just going to make it a child of the camera. So I'll right click on camera, go add child node, and this is just going to be a spatial node, and this is going to be for the gun muzzle. So where are we going to be spawning the bullet to then shoot? Okay, so with the spatial here, I'm going to rename it to muzzle. And we want to position it basically just at the muzzle of the gun here. Now with this view it's kind of hard to orientate yourself, so what we can do in Godot is have some automatic orientations applied to the camera here, the scene camera. And for that you do need a numpad, so make sure on your numpad you have numlock turned on, so you have the light with the numlock on. And then I'm going to press 7 to have an above view right here. And what we're going to do with the muzzle is drag it forward a bit, and in fact right now we're in perspective view. You can see that things change perspective as we zoom in, but if we press 5 we'll go into an orthographic mode so that there is no depth shown. So what I'm going to do here is hold down Shift, and with middle mouse we can pan across like this. I'm going to position this right about here. There we go. We can then press 1 to get a side view, and actually we'll press 3 to get this side view, and then drag that down to line it up like so. You can press 5 to get out of the orthographic mode, and there we go. We've got our gun model, we have the muzzle, and everything here should be ready to go. If we go back into the main scene now, what we can do is drag in our player.tscn into the scene, set their transform here to be 0, 0, 0. They should be standing in the middle of the field here with a, and they should be standing on top of the surface here. Now if we press play, you'll notice that it says no main scene has been defined, so we'll select the main scene right here, press play, and there we go. We got our camera, we got our gun model here, and we're ready to begin scripting. But before we do that, it's good practice to actually go to our player here, select the camera, and enable current right here. Just in case you do have multiple cameras in the scene, it's good to basically tell the game that this here is the camera we want to use. So there we go. Thanks for watching, and I'll see you in the next lesson. Welcome back everyone. In this lesson we're going to begin to script our player. We're going to have the ability to look around with our camera, move around as well, and jump and have gravity applied to us. We're going to create a first person controller here in Godot. So in the previous lesson we set up our player scene right here. I'll just open it up. We set up our kinematic body as our main node, then a collider, a camera, and as a child of the camera we have the gun model and the muzzle where the bullets are going to come out. So we got that all set up. Now what we need to do is select the player node here, and we are going to create a new script here in the inspector, and this script we'll just keep it called player by default. Okay, so we got the script right here up and ready to go. So the first thing we want to do is create our variables. First up, let's create some stats. So I'm going to separate these by some comments, and a comment you can just go hashtag and then write whatever you want. These won't get compiled with the code, as these are just for us to see. So first up, we're going to have some stats that we're not really going to be working with just yet, but we'll be needing them later on. So first up, we have our cur HP for our current health, and that is going to be of type integer, and by default that'll equal 10. We also need a max HP to know how much our health can go up to. That'll also be an int of 10 by default. Then we got our ammo, which is int again, and we'll have that at 15. And we have our score, which we'll have as an int, and that'll be 0 by default. So we're not going to be using these values just yet. Instead, we're going to be going down here, and we're going to create some physics variables. And these are going to be with the actual movement, jumping, and gravity. So first up, we have a move speed of type float. So we want very precise numbers. We can have decimals. And by default, we're going to have this equal 5. Then we want to have a jump force, so how much force is applied upwards when we want to jump. That is going to be of type float again, and we'll have that as 5 by default. And then we also want to have our gravity, which is also going to be float, and this is going to be, we'll have it at around 12. We can tweak this depending on if it's a bit too strong or if it's a bit too weak. Okay, so we got that. As well as this, we also need some variables for our camera looking. So with our camera, so I'll just look up cam look here. We need to figure out what is the maximum angle we can look upwards and what's the maximum angle we can look downwards, because we don't want to be able to look up and down and just do a 360 that way. We want to sort of clamp the vertical rotation. So here we'll have var for min look angle of type float, and this will equal -90. We'll also have a max look angle, so max look angle of type float, and this will equal 90 as well, so we can look 90 degrees up and 90 degrees down. Along with this, we also need a look sensitivity, because when we're moving our mouse around, it might be a bit too slow or a bit too fast, so we do want to be able to change the speed at which we look around. So we'll go var, and this will just be look sensitivity of type float, and this will equal 10. So we've got those set up. As well as this, we also need some vectors. We need to store our current velocity and the mouse delta, which is basically how far in which direction has the mouse moved in the previous frame. So we'll just have our vectors here, And these are going to be, first of all, var for vel for velocity is going to be of type vector3, so we're storing a x, y, and z position because we are moving around in 3D space, so our velocity can be in any direction. And by default, we'll just make this a new empty vector3 like so. And we also want the mouse delta. Now, since the mouse only works on 2 axes, horizontal and vertical, we only need to have a vector2 for this. So it's going to be our type vector2, and we're going to make it a empty vector2 by default. There we go. So we got that here. Now what we need to do is actually get our components, because on our player node right here we have a few things that we need access to, such as the camera and the muzzle. We need to know where the muzzle is in order to spawn bullets, and we need to know what the camera is in order to move it around. So I'm just going to go here, components, and we're going to have our var camera, which is going to be of type camera, and we want to actually be able to access this once the game starts. So I'm going to switch this variable over to an on ready variable, which basically means whatever is after this equals sign here will be called once this node here is initialized. And this allows us to basically look through our node structure and find the camera. So we can go get underscore node, and then we can just search camera, and it is going to get the camera node that it finds. Now we also need to get the muzzle, so we can go on ready var muzzle. This is going to be of type spatial, because this here is just going to be an empty node, and this is going to equal get underscore node. Now we need to get the node path to that node. Now it is a child of camera, so first of all we need to enter in camera slash muzzle. There we go. So that's how we access the muzzle node right here. And with all that set up, let's actually go ahead, press play, make sure there's no errors with any of these on ready variables right here. So we'll press play, and we are all good. There's no errors popping up here, so we can exit out of this. And from here, we've got all our variables. Now what we can do is actually start and setting up our physics, setting up our movement, setting up our jumping, our gravity, and looking around with the mouse. So first of all, before we actually jump into that, what we need to do is set up our actions, our key actions, because right now the game doesn't really know what move left, move right, move forward, move back means. It doesn't know what the attack button is, it doesn't know what the jump button is, so we need to define these things inside of Godot here. And to do that, we can go over to project settings, input map, and over here is where we can enter in our new actions. So first up, we're going to have one action. This is going to be move underscore forward. Press enter to add it to the actions here. We also want move underscore backwards, move underscore left, move underscore right. We also then want jump, and we want shoot. So we got these 6 new actions here, and what we want to do is assign a key to it, because right now they got no keys. You can see some of these other actions here that are default in Godot do have actions, or do have keys corresponding to that action. So for move forward, let's click on the plus icon right to its right, select key, and then we can just click on whatever key we want that to be assigned to. So move forward, I'm going to set it to W, press OK. Move backwards, we're going to set that to S. Move left, we'll set that to A. Move right here can be D. Jump, we'll have it as space, and shoot here is going to be a mouse button, so I'm going to click on the plus, choose mouse button, and as you can see by default it is left button right here. You can choose from all the various different mouse buttons. Device, with device here it doesn't really matter what you select. You can select device 0, but I'm just going to select all devices just to make sure, because there's no multiple controllers in this game, so all devices is just the safe way to go. Click add, and there we go. We're going to have move forward, backwards, left, right, jump, and shoot actions all set up, ready to go, so we can start detecting them inside of our script. So I'll click close right here, and what we're going to do now is actually start to create our function which is going to run the physics, and this is going to be the underscore physics underscore process function. So let's create it right here. So I'm just going to go func underscore physics, and what you should see is it automatically pops up with a selection. We can just hit enter, and it creates the physics process function. Now, this function is built into Godot. More specifically, it is built into our player's kinematic body node right here, which we are extending from at the top, so we do have those attributes we can access. And this function gets called 60 times a second. This is a consistent update function. Now, Godot also does have the default underscore process function, which gets called every single frame. But doing physics in the process function at times might not be the best because that is not a steady call rate. That gets called as many times as you have frames per second, so you might be fluctuating between 60, 100, so the process function can be called any number of times during a second, whereas the physics process function gets called at a consistent 60 frames per second, which is good for physics as you don't want variations in the time step. So we got the physics process function right here, and we're going to be doing a number of things here. And we'll be doing a number of things here, such as detecting inputs, moving the player, jumping, having gravity being applied to us, and we'll be working on that in the next lesson. Welcome back, everyone. In the previous lesson, we started to create our player script right here. We entered in all of our variables we're going to be using for now, and we also created the physics process function, which gets called 60 times a second. Now, there is going to be an error right now because we don't actually have anything in the function, so it's got some problems of it being empty, but let's go fill it in. So first of all, what we want to do is reset our x and z velocity of this velocity vector right here, because when we let go of a button, we don't want to continuously be moving in the same direction as when we were holding a button down, so we want to stop once we let go of a button. And the reason why we're not just resetting the vector as a whole is because we want to maintain the y velocity, because if we're falling and we let go of a button, we don't all of a sudden want to reset our y velocity. We want to keep falling down. So here we're going to reset the x and z velocity, and to do that we're just going to go vel.x equals 0 and vel.z equals 0. Now what we need to do is create a new vector2 to basically get our inputs, because what we're going to do is we're going to be checking to see if we've pressed WASD, and these keys are going to correlate to if we're moving forward, if we're moving back, if we're moving left, if we're moving right, and we're going to store that in a temporary variable, which is going to be a vector2. So we'll go var input equals vector2. So we're going to be storing the left, right, and up and down inputs in this vector right here. And we're going to do that in movement inputs. So we're going to be checking first of all if we are pressing the forward button. So if input.is_action pressed, so every frame that this action is being held down, this is going to be true. So we want to check for move forward, colon at the end. And what we're going to do if this is true is we're going to set input.y minus equals 1. So right now if we press move forward, y is going to be -1. Now we need to do this for all 4 movement axes, so then we can go if input.is_action pressed, and we want to check for move backward. Then we are going to go input.y plus equals 1. Okay, as well as this then we need to check the left, right, then we're good. So I'm just going to copy this right here and paste this twice more. We'll check move underscore left and then move underscore right, like so. Okay, so if moving left, we want to go on the x-axis and go minus equals 1, and if we're moving right, we want to go plus equals 1 on the x-axis. So we've got our movement inputs, and this input vector here is being changed depending on which buttons we have held down. Now what we need to do is normalize this vector, and what normalizing it does basically means that the magnitude or the total of all the axes added together will equal 1. And the reason why we want to do this, especially for a character controller, a player controller, is because if we are holding down, let's just say, the forward and right button, we're going to be moving at a diagonal angle, and this movement is actually going to be faster than if we were just moving forwards or backwards or left or right. If we're moving at an angle, by default it is going to move us faster. So we want to normalize this vector so no matter which direction we're moving in, it is always going to be the same speed. So to do that, we're just going to go input equals input.normalized, like so. Okay, now that we have our inputs set up and ready to go, what we want to do is get our forward and right directions of our player. We want to know which way is our forward direction and which way is our right direction, and we're going to need these in order to actually figure out which way we should set our velocity, because right now if we just set our velocity, it's not going to take into consideration which way we're looking. It's just going to move us along the global X and Z axes. So what we need to do is we need to get the forward and right directions, and to do this we are going to create a variable here called forward, and this is going to be equal to our global underscore transform. So we're getting our global properties instead of our local properties, because local might be different depending on if we're a child of another object. So we're getting the global transform dot basis dot z. So this returns us the direction we are looking forward. Now to get the direction we are looking towards, or not direction we're looking, but the direction to our right, which we'll need for moving sideways, we're going to go var right equals global underscore transform dot basis dot x. So now that we have our forward and right direction, what we can do now is create a new vector which is going to store the relative direction. So this is what we're going to be then assigning to our velocity in order to move in the direction we are facing. So I'll create a new var for our vector, which is going to be called relative direction here. And this is going to be equal, in parentheses here, we're going to do a bit of a calculation to figure out which way we're facing with our forward and right direction, as well as our input here, which we're going to be using to figure out which way we're going to be moving. So we want to go forward multiplied by input.y plus right multiplied by input.x. And this is going to give us a vector 3, which is going to be the direction we're going to move in. So we got that. Now what we need to do is we need to set the velocity. Now with our velocity vector, we don't want to set the x, y, and z. We just want to set the x and the z, because the y is going to be set a bit later on after this, depending on if we're jumping or not. So for this, we're just going to go vel.x equals relative direction dot x multiplied by our move speed, because we do want to have that variation in our move speed if we want to increase it or decrease it later on. Then we got vel.z equals relative.z multiplied by move speed as well. So our velocity vector is being filled in. Now what we need to do is apply gravity. So with gravity here, we'll go apply gravity. All we're going to do for this is just go vel.y minus equals gravity multiplied by delta. So each second we are going to be adding this amount of downwards velocity to ourselves, and this multiplied by delta pretty much converts this into per second rather than per frame, because if we didn't have this, then we'll be subtracting gravity, which is around 12 at the moment, so we'd be adding in negative 12 velocity to our player along the y-axis every single frame, 60 times a second, which is a lot. Instead, we're going to be adding that every second, which is done by multiplying by delta, which is the time duration between each frame. So we're setting our velocity, we're applying our gravity. Now what we need to do is just move the player. Have this velocity vector be applied to the kinematic body so we can move. And what's really handy with this is that the kinematic body node comes with a function which allows us to easily do this. So move the player. What we're going to do is just go vel equals move underscore and underscore slide, which is also includes some collision stuff as well. And we just want to give it the property of our velocity and the ground normal. So which direction is the ground facing? That is going to be vector 3 dot up, which is a built-in vector which is just 0, 1, 0 for up. And there we go. So we're moving the player here. Now all we need to do finally for this function is add in the ability to jump, and that can be done by going. So we'll just have jumping, and that can be done by going if input.is underscore action underscore pressed. So if we're pressing down the jump button, then what we also want to check is, are we grounded? Because if we can just press the jump button, then we'll be jumping continuously. So we want to check also and is underscore on underscore floor, which is built into the kinematic body as well. If we're on the floor and we hold down the jump button, then what we want to do is go vel.y equals jump force. So we're setting our y velocity to be whatever the force is to jump upwards. Okay, there we go. So we got our function right here. We got all this functionality built in. Now let's press play and test it out. So I'll press play. So we can't look around right now, but if I go WASD, you'll see that we can move. Space jumps us up. It's not a big jump, but we could tweak that a bit. And yeah, there we go. We can move around, we can jump, we have gravity applied to us. In the next lesson, what we're going to do is focus on setting up the mouse look so we can rotate our head around and move in the direction we're looking. So thanks for watching, and I'll see you all then in the next lesson. Welcome back, everyone. In the previous lesson, we set up our ability to actually move around, jump, and have gravity being applied to us. So in this lesson, we're going to be focusing on actually being able to look around with our camera. So first of all, what we need to do is figure out how and where is our mouse moving. What is the direction our mouse is moving in, and how far is it moving? And we're going to be checking that inside of a built-in function to Godot, which is called func_input. And it comes with an event parameter. And what this function does is it gets called whenever an input is detected in Godot. So whenever a keyboard input is detected, if you click a mouse button, even if you move the mouse, this function here gets called with the corresponding information sent over in the event parameter here. So what we want to do is check first of all if this event right here, is that to do with the mouse motion? So is this to do with moving the mouse? If it is about moving the mouse, then we want to set the mouse delta to be basically the direction that the mouse is moving in. So we're going to go if event is input event mouse motion right here. So if the event is to do with mouse motion, then what we want to do is just go mouse delta equals event.relative, like so. Okay? And what we can do now is up inside of the process function, which gets called every single frame. We're doing it in the process function and not the physics process, because if you've got stuff that isn't really to do with physics, it's recommended that you just do it in the process function. So I'm going to create the process function here, _process, which gets called every frame. And what we want to do here is, first of all, we want to rotate the camera along the x-axis, because with this camera setup, the way we're going to be doing it is we're going to be rotating our camera vertically. So we're going to be rotating the camera node up and down so we can look up and down, but we're not going to be rotating the camera left and right. Instead, we're going to be rotating the actual player node here left and right, and the camera is going to be staying still. So the camera is only ever going to be rotating up and down, and if we look left and right, we're going to be rotating the entire kinematic body node left and right. This just makes it a lot easier for when we're calculating stuff such as the forward direction, which we done previously. So to do this, we're going to go camera.rotation_degrees.x, and what we're going to do is we're going to subtract equals, so we're going to take away from this the mouse delta.y, so the up and down of the mouse movement, multiplied by look sensitivity, multiplied by delta, so it's converted into in terms of seconds, so it's a bit smoother. And now what we want to do is clamp the rotation, because if we have our mouse and we move it upwards, the camera's going to rotate upwards, and it's going to keep rotating upwards until it loops back around, and it's just going to be really weird and not really fit with this first-person controller. So we want to clamp it so we can only look so far up and so far down. So we'll clamp camera x-axis. And to do this, we're going to go camera.rotation_degrees.x equals clamp. Now this clamp function takes in 3 values. It takes in the value that we want to clamp, then we need to give it a minimum and a maximum. So the value we want to clamp is going to be the camera.rotation_degrees.x. The minimum is going to be the min look angle, and the max is going to be the max look angle. Just like that. Okay, so we got that all set up. Now we need to set up actually rotating left and right, because right now we can look up and down. Let's look left and right. So we're going to rotate the player along their y-axis here. And to do this, we can just go rotation underscore degrees, because this is the script is attached to the player that we're rotating. So we'll go rotation degrees dot y equals, oh, we need to go minus equals mouse delta dot x multiplied by look sensitivity multiplied by delta. And we don't have to clamp this value, because looking left and right, there's no minimum or maximum angle we can look. We can look full 360 degrees horizontally, so we can just leave it like that. Finally, we got to reset the mouse delta vector so that we don't keep looking in the direction that the mouse is moving. So we'll go mouse delta equals vector 2 to reset it. And that is pretty much it. So what we can do now is press play, and hopefully it works. Alright, so we can look around, and there you go. We can look left, right, up, down. But something you might want in this game is for the ability for the mouse to not be free like this. Because right now, if we look outside of the window, the mouse, it doesn't continue to track. If we move it in, it continues. But it's very weird, and it's not that usable. So what we need to do is lock the mouse cursor in the middle of the screen and hide it. So when we move our mouse, we don't see the cursor, and the cursor can't go off screen. Now to do that, we're going to go to our player script here. We're going to go to the top of the script, and we'll create the underscore ready function. Now the underscore ready function gets called once the node is initialized. So this is going to be called once right at the start of the game. And what we're going to do here is we are going to hide and lock the mouse cursor. So to do this, we want to go input dot set underscore mouse mode. And with this, we can give it a number of different modes right here. There's captured, there's confined, there's hidden, and there's visible. Visible is what it is right now. It's visible on screen, and we can move it around freely. Hidden basically just hides the mouse cursor, so we can't see it, but it's still going to be moving. Confined means that it is just going to be confined to the screen. That's kind of what we want, but we don't want the mouse visible. So we're going to be using mouse mode captured, which hides the mouse and locks it into the center of the screen. So there we go. And now what would happen is if we press play here, you'll see that when we press play, the mouse cursor disappears, and here we are with our character. We can look around, the mouse doesn't appear off screen, and if we move, you'll see that we move in whatever direction we are looking at. And that is being done by getting the forward and right directions and creating the relative direction in order to actually set this up. If we look up, you'll see that we don't continue to look up, we sort of clamp at the top here. It's kind of hard to see, so I'll go near a tree. You see that we look up, it sort of stops. If we look down, it also stops. So we can't look all 360 degrees up and down, but left and right, that is possible. Jumping works as well. And yeah, so that overall is our player controller setup. We have the movement implemented, we have the camera looking implemented, and that is pretty much how you set up a basic character controller inside of Godot. In the next lesson, we're going to be focusing on actually setting up the ability to shoot bullets, as that's going to be one of the main mechanics in this game. We got our gun here, we got that muzzle object set up. Now all we need to do is be able to left click on the mouse button and shoot out a bullet. And from there, we'll also set up enemies that we can shoot, pickups, and the UI system later on. Just something quickly also, you may notice that you can't really get out of this window right here. You click escape, nothing really happens. It's kind of hard to get out of this window, so what you can do is you can just hit Alt F4 to quit out of that little gameplay window. It goes back to the Godot editor and it stops playing the game. So yeah, there you go. I'll see you all in the next lesson.